We'll move right along next to Nicholas Kieffer and his mentor, Dr. Kevin Sikowski. Would you like to introduce your intern?
Yeah, sure. Nick is from Lakeland, Florida. He's a senior and started school, I believe, last week, and is also taking community college classes. And Nick did a project on air quality as well this summer. And who knew it was going to be such a big summer for air quality studies? So, Nick.
All right. Hi, I'm Nicholas Kieffer from Bartow High School, and my mentor is Kevin Sikowski from the University of Toledo. And my project was an analysis of the air now fire and smoke map using purple air sensors. So to start, I just want to look at air quality. The air quality index is a measure of pretty much the levels of air pollution. And this is important because there are a variety of bad effects of having high levels of air pollution. There are health effects, such as just like respiratory infections, and then there's like acid rain. It can affect photosynthesis in plants. There's just a variety of bad effects of having high air pollution, especially to those susceptible to respiratory infections. And then, sorry. And then wildfires these are large, uncontrollable, and unpredictable fires. So have many effects, most notably the massive property damage they can do. But within this investigation, I wanted to look at the wide-reaching smoke that they release because it contains many air pollutants. And so over the summer, there were a variety of wildfires. And like we had wildfires in Western Canada that would reach over like to the east coast of the US because like the smoke would just reach that far out. And so I wanted to investigate whether or not there was a statistically significant difference in the AQI as a result of the smoke. So I hypothesized that exposure to smoke would increase AQI because smoke does contain particulate matter. And so I was able to measure these two things using AirNow and Purple Air. So the AirNow website is run by the US EPA, and it gives data on wildfires and smokes within the United States. And so that's displayed in the top right. The Purple Air map, that has sensors which have like accessible values for the AQI throughout not just the US, but throughout the world. And pretty much anybody can access the Purple Air map and even create or like even buy their own sensor and upload it to the map, which is even what I was able to do. So I was able to get my own Purple Air sensor, and I was able to use it to collect data for my project. And so with this sensor alongside 111 others from the continental US. So I wanted to create like a diverse sample. So I collected data from a variety of regions in the US. I looked at like more coastal versus inland and more rural versus urban areas. So for each sensor I first like made sure that it had reliable data, because on the Purple Air website there's like a little correlation for the sensor. And I would even sometimes pick like multiple sensors in the same location just to test whether or not they kind of correlate with one another. And in the bottom right, I have my Excel spreadsheet. And so with each Purple Air sensor, each of those sensors, like the location is on the AirNow website. So I could use that to determine whether or not there was smoke predicted by the AirNow website in the location. And I was able to use the fact that the AirNow website predicted whether there was smoke in the Purple Air website to give me the AQI at that location to create a spreadsheet where it had values just of each of these samples or for whether or not there was smoke or not. So this is some data from my sensor in Blythe, California, or from one of the sensors I used. So this table shows some of the sample statistics and this histogram. The red is the data for when there was smoke present, blue is when there was not smoke present, and then the purple is the overlapping data. And from this histogram, you can see that when there was smoke present, the values tended to be slightly higher, but there was most importantly like a much greater variation, and it was more likely to have like a very high AQI relative to when there was no smoke present. And so I decided to run a 2-sample t-test for means to determine whether there was like a difference between the mean AQI when there was smoke versus when there wasn't. And so the null hypothesis is that the mean when there is smoke, the mean AQI when there is smoke, and the mean AQI when there isn't smoke is the same. The alternative hypothesis was that when there was smoke present, the AQI would be greater. And so I show my calculations for the data. So this was the difference in means. It was 3.58. This was the calculated standard error. It was 2.10. And then when you divide those, you get your t-value 1.71. And so these are the degrees of freedom, 93.71. What's important about this is that the higher it is, pretty much makes this t-distribution more normal. And with a higher sample size like I had, it gives you a higher degrees of freedom, which gives you a more normal t-distribution. And so at the bottom right, this t-distribution, the red bar represents the t-value, and everything shaded to the right of this red bar is the p-value of 0.0456, which what this means is that if the null hypothesis is true, if the mean AQI when there is smoke and when there isn't smoke are the same, there's a 4.56% chance of getting data like this. And generally so that says that there's like less than a 1 in 20 chance of getting data where the samples are this different. So since this is below 0.05, it's considered statistically significant. And looking at the overall results, unfortunately 19 sensors were unusable just due to the fact that either their correlation was bad or they were removed from the map. And then some sensors weren't usable because there was not enough variation within the data. There was a lot of smoke like in the Midwest this year, so I didn't have enough data from when there was not smoke to really compare the two samples. But overall, looking at the data, looking at the p-values that I was able to calculate, a majority of them were statistically significant, which suggests that the air now filter or the air now map, the fire and smoke map, is a good predictor of AQI. But also, I wanted to note that the p-value, for the most part, for most of the p-values decreased as I continued to collect data over the last 2 weeks, which suggests that had I kept collecting data for like a longer period of time, my results may be different. Now here I have a map of all of the p-values that I was actually able to obtain. And so the larger the dot is, the larger the p-value is. And so on the East Coast, the p-values were very small, which I believe is due to the fact that the Canadian wildfires the smoke from those wildfires tended to go more towards the eastern US. And a similar thing happened in Oregon, which had wildfires within its borders over the last few weeks. And so in Oregon, there were also very low p-values. And so I think that both of those happened because smoke from wildfires was being pushed directly towards those sensors. And then within California, within Los Angeles and San Diego, 4 of the 5 largest p-values were there. And then also looking at New Mexico and Utah, in Albuquerque, which is New Mexico's largest city, that's where its largest p-values came from. And in Utah, in Salt Lake City, its largest city, that's where its largest p-values came from. So it appears that the more urban areas had higher p-values than more rural areas, which suggests that those areas have other sources of air pollution aside from just the smoke that could be influencing the data, whereas the more rural areas, the smoke is the major influence of air quality. And so my conclusion, first thing is that the purple air sensors, while they, I believe, are quite valuable as they're easily accessible to everyone, I think for like a longitudinal study, they are unreliable considering that over 15% of mine were unusable. And then for the most part, the presence of smoke predicted by the AirNow sensors did tend to be associated with a higher AQI value. I believe that the use of the AirNow website, like the fire and smoke map, is a very good predictor of the AQI in the more rural areas. However, it was quite ineffective in urban areas. And I believe that this disparity between urban and rural areas can make for a very interesting topic of study in the future for air quality and really any other measure of pollution. And then lastly, I want to give a thank you to a few groups. So I want to thank the N3 network and NASA for putting on this program, for all the mentors and giving us all this amazing opportunity. I want to thank Purple Air and AirNow for just having easily accessible data to me and everyone else. I want to thank Arcus for having their good mapping website that was easy for anyone to use. I want to thank my teacher, Miss Frisbee, who recommended me for the M3 program. I want to thank my parents for supporting me. And most importantly, I want to thank Dr. C for helping me out throughout the summer. And I really appreciate and enjoyed learning from him. Thank you.
Awesome. Thanks, Nick. Let's give Nick a virtual hand. Awesome work.
Yes, it makes me really glad that I wasn't on the East Coast because we've had our share of smoke in California. So I did not mind missing the Canadian wildfire smoke this year for sure. And I have a few purple airs myself, but it's very interesting to see the correlation or lack thereof with the AirNow information. Any questions for Nick? It's a quiet group for questions today.
Just means we had very thorough presentation.